Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone to pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Don't worry, at the end of this question you will have the complete clarity about the right answer as well as explanation. Now, I believe we have tried, so let's start. So the question, what is the major product in this reaction? What is this reaction? This is actually 2-methyl cyclohexanone reacts with LDA first, means LDA in THF. Second step is PHACCl. Third step is H2O2 heat. So it's a multiple step reaction. So I suggest in this case, let's go stepwise. Now first step is LDA. By the way, LDA is actually a bulky base. Now why it is bulky base? Look at, nitrogen is attached with two bulky isopropyl group. So that's why it is a bulky base. This anion is there, that's why it acting as a base. So what it does? It is actually, remember, it is a selective proton abstracting reagent. What do I mean? Means it doesn't abstract every proton. It abstracts proton selectively. Where? Obviously from less bulky side. By the way, this is acting as a base. So obviously this molecule is acting as acid. So first you should remember that point number one, that acidic proton. You need to find out acidic proton. Second point, less bulky. So these 2 points will help you to decide that, sir, from where the proton abstraction will take place. Logically, two options are there, from here and here. By the way, why I am selecting this? These two positions are the alpha position with respect to carbonyl. And we know the carbon ion produced at the alpha position is resonance stabilized by the carbonyl group. So that's why this proton's acidity is significantly higher. Now if you look at the second point, less bulky, obviously this proton is lesser bulky. That's why the base LD abstracts this proton and it generates this carbon ion. Obviously, as I told just some time before, it has a resonance stability. How? It pushes in this way, the negative charge is delocalized, and we know delocalization means stabilization. So in this way the carbon ion is stabilized. By the way, remember, carbon ion, it's actually an electron rich species, so that's why it can act as electrophile. No, it can act as nucleophile. So who can act as electrophile? Option 2, PHSECl. Why? Actually, if you look at these attacks here, and Cl leaves, by the way, chlorine minus electronegative atom carrying negative charge, so it is relatively more stable. That's why this step takes place. And in this way, what happened? Selenium got attached with phenyl. By the way, selenium belongs to group 16, so it has logically two lone pairs of electron. Okay, now in the next step, what is expected? There is hydrogen peroxide and heat. So first, hydrogen peroxide. What hydrogen peroxide does? We know hydrogen peroxide is an oxidizing agent. By the way, I've already discussed a dedicated lecture regarding the behavior of hydrogen peroxide. Please visit for further learning. It's a very interesting reagent. So what we can expect here, that hydrogen peroxide will oxidize this selenium to selenium double bond O. Why? Because if you look at this, selenium belongs to the group 16. I agree, definitely it belongs to the group 16. But if you look at the position, so this is selenium, it belongs to the fourth row. Means you can say, sir, size is significantly higher. Not only that, size is significantly higher means the outermost electron is significantly away from the nucleus. So what is the consequence? The electron density is weakly attracted by nucleus. So it could be taken away by someone easily. And what is the definition of oxidation? Oxidation, one of the definition, there are three definitions. One of the definition is removal of electron. Since the electron is relatively weakly attached to selenium as a form of lone pair, that's why it is easier to remove, because size is higher, electron is far away from the nucleus. So that's why selenium got oxidized. Any other positions are not oxidized. Next point, what you can expect, that sir, heat is there. What happened because of heat? So it is actually, student, it's a cyclic reaction. So what happened, these oxygen abstract this proton, this lone pair comes here and this selenium leaves. So what is the consequence? Obviously there is actually a double bond formation. Okay, so this is the overall reaction, this is the product. From here what you have learned, that first step, LDA abstract protons selectively from less bulky and relatively more acidic. By the way, this proton is expected to be relatively more acidic because methyl group has its plus I effect also, or hydrogen doesn't show any plus I effect. So LDA selective proton abstraction, PHACCl, phenyl selenium chloride, this selenium center is delta plus, or it can act as electrophile. Third step is actually hydrogen peroxide can easily oxidize this selenium lone pair because of its larger size, lesser electronegativity. And fourth part, that is in presence of heat, it undergo a cyclic reaction and ultimately it can result in an alkene, more specifically if I say alpha beta unsaturated alkene. So this is the answer is option B. Now if you ask, sir, why not C and D? Suppose this question appears in your exam. Remember, what are these options? This is actually oxidation of ketone to ester, Baeyer-Villiger oxidation. Hydrogen peroxide, no. So for that purpose we use per acid, for example, peroxy trifluoroacetic acid, peroxyacetic acid, MCPBA, metachloroperbenzoic acid, etc. reagent. So these two options are actually false option. You should have proper knowledge about name reaction. By the way, if you have any doubt about Baeyer-Villiger's reaction, please visit. I have already made dedicated lectures previously. So this is the answer. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.